Our planet is enveloped by an invisible magnetic shield, our only line of defense against deadly solar radiation. But this shield has weakened. Directly above us lies a giant gap known as the South Atlantic Anomaly. And while we on Earth feel completely safe, chaos is unfolding in orbit. As soon as satellites or the ISS cross this zone, their electronics go haywire under the onslaught of relentless storms of charged particles. But the most terrifying thing is happening right now. This dent in our shield is mutating. It is rapidly expanding, and the latest satellite data shows the unthinkable. The anomaly is literally splitting in two. What does this mean for the planet's future? Why is our shield cracking at the seams? To find the answers, we'll have to descend into the very depths of hell, to a depth of nearly 2,900 kilometers beneath the Earth's crust, where the outer layer of the Earth's core rages, a scorching primordial ocean of boiling liquid iron and nickel. Down there, in that subterranean inferno, temperatures soar to an incredible 10,000 degrees Fahrenheit. That's hotter than the sun's surface. The churning currents of molten metal act like a giant dynamo, generating colossal electrical currents that create our magnetic shield. If it were to disappear even for a second, as NASA experts warn, the relentless solar wind would simply strip away our atmosphere and hurl it into outer space, leaving Earth lifeless. But this protective dome is far from perfect. It is warped, asymmetrical, and constantly shifting. Right now, something terrifying is unfolding deep beneath Africa. According to the latest reports from ESA satellite missions, some of the magnetic field's lines of force there are literally going haywire. Instead of shooting into space to deflect radiation, they bend and plunge back into the core. Scientists call these backflow spots. These magnetic whirlpools are sucking the power out of our shield, and it is precisely over this gaping hole that the South Atlantic Anomaly is spreading. That very South Atlantic Anomaly I mentioned earlier, and it's changing so rapidly that we can observe its alarming transformation literally within a single decade. How do we know this? Thanks to an unprecedented mission by the European Space Agency called SWARM. Imagine 3 high-tech satellites that, like a swarm of bees, continuously scan the Earth, compiling the most detailed map of our magnetic shield. What their radars are showing is making scientists nervous. Since around the mid-2010s, this breach has begun to spread aggressively. The magnetic field there is rapidly losing strength, and the anomaly itself is splitting right before our eyes into 2 gigantic funnels. And even though here, down below, we are still protected by a thick layer of atmosphere, we are still in the line of fire. Our civilization is critically dependent on space, and most of the satellites that provide us with communication, internet, and navigation are in low Earth orbit, right in the line of invisible fire. Just a couple hundred kilometers above our heads. But within this anomaly, the laws of space change. Earth's radiation belts bend down toward the surface here like an invisible gravitational trap. When a satellite enters this space, it is no longer a routine flight. It is a race for survival through the death zone. A single powerful burst of charged particles and the tiny bits inside the computer chip flip. A split-second glitch, and the sensor goes blind while the control system goes into a deep reset. Satellites are forced to switch to safe mode immediately, shutting down all their most valuable systems just to avoid being fried alive. And this happens more than once a year. Hundreds of spacecraft cross this cosmic Bermuda graveyard several times a day. Every such passage is a game of Russian roulette with the fate of our digital lives. Even the legendary Hubble, which has given us the clearest images of distant galaxies, bows to this force. It is forced to stop working and literally close its eyes every time it flies over this zone so as not to lose its ultra-sensitive electronics forever. Why is this dangerous for us? If the magnetic shield continues to weaken, the threat will extend beyond orbit. global digital blackout? Imagine that in an instant, your phone's navigation starts showing incorrect locations by miles. Bank transfers freeze due to a satellite synchronization failure, and cellular service simply disappears. This isn't a movie scene, but a real risk of satellite constellation failure. Power grid collapse. According to NASA, an intensification of the anomaly could lead to the generation of powerful induced currents in ground-based power grids. This could result in the widespread failure of transformers and plunge entire cities into darkness for weeks. Threat to aviation. At high altitudes, background radiation could spike so high that airlines would have to reroute flights to protect passengers and aircraft electronics from being fried alive. Hubble is a true space veteran who has witnessed the birth of stars and the death of entire galaxies. But even this titan backs down in the face of the South Atlantic Anomaly. Every time it approaches this gap, it literally whispers, "I'm out." The telescope freezes, stops observing, and shuts down its ultra-sensitive detectors. It is too valuable to gamble with radiation, where the entire mission is at stake. And this isn't just paranoia. Ask the Japanese, who launched Hitomi, a next-generation X-ray telescope in 2016. It was a technological masterpiece created to study monstrous black holes and supernova explosions. It was supposed to operate for years and revolutionize our understanding of the universe. But fate had other plans. While flying over an anomaly, Hitomi's electronics suffered a fatal malfunction. The orientation system went haywire, deciding that the satellite had begun spinning out of control. In an attempt to correct the situation, the computer fired the thrusters at full power. As a result, Hitomi spun so violently that its solar panels were simply torn off by centrifugal force, and the satellite itself shattered into pieces in the silent void. Billions of dollars and years of labor turned into space debris in a matter of minutes. And what does this mean for you personally? It might seem like, what does a Japanese satellite have to do with you? But this invisible threat is much closer to your wallet and your comfort than it seems. Your smartphone's glitches. Have you ever noticed that your phone suddenly reboots or your GPS loses you out of nowhere, even though the signal is excellent? Due to the weakening of the magnetic field, high-energy particles penetrate the atmosphere more easily, causing micro-glitches in the operation of cloud servers through which all your data passes. Rising living costs. Every loss of a satellite like Hitomi or the failure of Starlink communication devices results in massive insurance payouts and losses. Who pays for this? Ultimately, the consumer. Prices for satellite internet, international communications, and even airline tickets, due to the need to fly around dangerous zones, will inevitably creep upward. And risk to air travel. If you fly frequently, be aware. During strong surges in the anomaly zone, radiation levels on board an aircraft can be equivalent to several X-ray sessions. Airlines are already beginning to monitor NASA reports more closely to avoid exposing crews and passengers to unnecessary radiation. The loss of Hitomi was not merely a technical glitch. According to official data from the Japan Aerospace Exploration Agency, JAXA, it was a catastrophic chain of failures in the orientation system, triggered specifically by the spacecraft's passage through the South Atlantic Anomaly. A mission costing billions of dollars, on which the planet's brightest minds had worked for years, turned into a cloud of debris just a few weeks after launch. But why is this happening right now? Why does this dent in Earth's shield behave like a living organism, growing and, according to the latest maps from the European Space Agency, ESA, literally splitting in two? To understand this, imagine that deep beneath Africa lies a giant cauldron of bubbling liquid metal. The currents in this cauldron are constantly changing shape. This can be compared to a simple but vivid experiment. Imagine that you are holding a powerful magnet under a table, and a thin sheet of metal lies on the tabletop itself. If you start moving the magnet, or if it begins to lose its uniformity, the steel sheet on the surface will react instantly. The same thing happens to our planet. What does this mean for the average person? For you and me, this boiling cauldron beneath our feet is not just a geological abstraction. Here's how it affects you personally. 1. Malfunctions in smart homes and electronics. NASA experts warn that as the anomaly grows, the density of charged particles in the upper atmosphere increases. This can lead to spontaneous malfunctions in highly sensitive home electronics or the cloud services we use every day. 2. GPS accuracy. Your food delivery or taxi might start wandering through neighboring streets. Magnetic disturbances affect the transmission of signals from satellites to your smartphone, introducing errors of meters and sometimes even tens of meters. 3. Internet stability. Backbone cables and communication systems on Earth are also susceptible to geomagnetic currents. In the worst-case scenario discussed by researchers in the journal Nature, the expansion of the anomaly could lead to more frequent regional disruptions in the global network. If you start moving this magnet under the table, the metal sheet on top will mirror its every movement. A dent will appear. Add a second magnet or shift the first one, and that dent will stretch or even split in two. This is exactly what is happening right now beneath our feet. According to the European Space Agency, ESA, streams of molten iron in the Earth's core are changing direction, creating new zones of weakness. As soon as two pockets of turbulence form below, the protective dome above them inevitably sags, creating a double breach. And this is where curious science turns into a real problem. After all, if the magnetic shield is capable of such a radical restructuring in just 10 years, what consequences should we prepare for? Hidden threats, health, and the environment. Your concerns about health are scientifically grounded, although the mechanisms at play here are more complex than mere glitches in the brain. 1. Surface radiation background. Under normal conditions, the atmosphere and the magnetic field block 99% of cosmic rays. However, an article in Nature discusses the hypothesis that when the shield is critically weakened, as in the SAA zone, secondary particles can reach altitudes where passenger airliners fly. For frequent flyers and flight crews, this means an increased risk of cumulative radiation exposure, which is associated with the risk of DNA damage in the long term. 2. Disruption of biological rhythms and migration. According to NASA research, many animals, birds, whales, and sea turtles, use the magnetic field as an internal compass. The splitting of the anomaly in two creates magnetic mirages, causing entire populations to lose their way, wash ashore, or perish before reaching their feeding grounds by summer, dealing a blow to the ecosystem on which humans also depend. 3. The ozone layer under attack. Scientists from the ESA express concern that the intense bombardment of the atmosphere with charged particles in the anomaly zone could trigger chemical reactions, destroying the ozone layer. And this is a direct threat to all of us. Less ozone means more harsh ultraviolet radiation, causing retinal burns and skin cancer. An economic apocalypse in your pocket. 1. Logistics collapse. If the anomaly disrupts GPS, global trade will grind to a halt. Tankers at sea and unmanned delivery systems rely on ultra-precise positioning. Any delay or navigation error caused by magnetic storms will lead to shortages of goods and a sharp spike in prices on store shelves. So, did today's post satisfy your curiosity? If so, now's the perfect time to reinforce what you've learned. Give it a like. It's the best way to say thank you for this content and help the algorithms show it to other truth seekers. Subscribe to the channel. Here, we don't just regurgitate the news, we uncover the invisible mechanisms that govern our planet and our future. Even more exciting analyses are coming up, from the mysteries of deep space to the secrets of AI. Share this video with your friends, especially those who complain about poor reception or navigation glitches. Let them know it's not the provider's fault, but the Earth's core and the capricious sun. Leave a comment. Have you noticed any strange technical glitches in recent months? Maybe you've also seen the northern lights in places where they've never been seen before. See you in the next episode.